Okay, so we will start. So we were looking at linear probing, right? And we had already discussed about the searching technique, the way to search in linear probing. So today we will look into the other functionalities. Deletion. So let's say at some point in time, the constitution of the table is as follows. Okay, so this is the situation of the hash table. Now, suppose you have to remove 15. Okay? So then, if you have to remove 15, what is the adjustment that you need to do after the deletion?
Uh, we have to bring one element back, sir.
Only one element?
At
Two
least
has
one
to be
element.
brought. Anything else is not required. If 2 comes to its correct position, then what does it mean, or what does it immediately indicate?
So three has to come to its
3 has to
position.
come to its own place, 4 has to come to its own place, 5 has to come to its own place, 6 has to come to its own place, 7 has to come to its own place. And this is a cumbersome process, right? Like in every deletion, if you need to do this kind of additional operations, that's a big overhead. So what people do is they usually play this nice trick.
Sir,
Please let me finish. They do this nice trick where once they have removed 15, they mark this place as available. Okay, and keep on the things as they were. Okay, now this actually requires a time to time cleanup of the A places. Okay, so you don't do the reordering immediately. You basically delay the reordering, and like after say some significant amount of time when a lot of processing has already been done, and you are seeing that there are a lot of A spaces here and there available, at that time you call a reorder. So this is basically also termed as a delayed reorder. Yes, now go ahead with your question.
sir, while reordering, sir, there might be a case that the all the elements, some of the elements are already in their correct place.
That's always possible, but you might land up into situations like this. So this is a bad situation that has been shown to illustrate the problem.
Okay. Okay.
If people are already there in their own position, then you don't need to do anything. Okay,
Yes.
suppose 10 is in its own position, so we will not reorder 10. He will do a reordering up to 7. That's all. So this is a bad situation illustrated.
Sir, in the 7 also, sir, in the group of 7, sir, suppose 3 and
Yes.
2 and 3 and 4 are its in original position.
Then don't need to do anything. You absolutely don't need to do anything. So this is just a bad situation illustrated to show how difficult deletion could be.
Sir, then we won't put A if the elements after that are at their own positions.
No, I don't understand. A is the
Like,
position which is just deleted.
okay, sir.
Okay. It has nothing
Sir,
to
if
do
we
with,
delete an element from its correct position, then do we need to mark it A still?
yeah, you always like use this convention of A. You always use this convention of A. When you have started this convention of A, even if it is in its correct position or wrong position, you keep it as A, and later on, as we are telling, so you allow this delayed reordering. So later on, at some point in time, you reorder.
No, sir, I am saying that if all the keys are always at their correct position, then reordering is never required.
Yeah, so basically that is a very win-win situation. You really don't have such a situation in real life.
Okay, sir.
Even if you consider an arbitrary distribution, you are bound to have this kind of problems, given the space is limited.
Okay, sir.
Sir, I didn't get what is delayed reorder. After some time also if we do, then it will be order of n, right?
What does it mean, or what does it have to do with order of n?
Sir, I didn't get what is delayed reorder.
So, like, what is the issue about not getting it? So I'm not getting like what you are not getting.
Sir, if we delete multiple elements, then we will have many A's, right?
We will have many A's. Fine.
Then
Do you?
what
So
it
like these many A's will. How is this going to help in the entire scheme of things? How is this going to help? Is it bringing any help at all? Is this bringing any help at all? Let's try to think backwards. Is it at all helpful?
yes, we need not check for other.
So does it in any way help find K?
No, sir.
Doesn't?
No, sir.
It does not help find K.
Like if we
Then
mark
what
it
is
K, then we need.
what is the use of like so it does not help, so your take is it does not help find K.
Yes, sir.
Now if I tell you that available is treated synonymously as filled in, and
It
the
will be.
search continues.
Sir, I'm saying that it will be same case as if 15 is there, right?
Yes, it will be same as is. So he will treat this as if there is no deletion, and he will proceed with the search. Okay.
Yes, sir.
That is
But
what
in
you
the
will do. That
if
is what
there
you
are
will
some,
do. No. Let us first agree with this. This is what you will do. You will continue searching.
Sir, we will treat it as it is a non-deleted object, but it is
Yes,
definitely not the case that we are. It is not the key that we are looking for. We will flag it.
absolutely. It is not the key that we are looking for. Okay, we are pretty sure that this is not the key that we are looking for. Okay, and the search proceeds. So now coming back to this delayed reordering question. So why don't you think that this will help?
sir, I'm saying that it will be same as the original case. It won't improve the case. That's what I'm saying.
What is the original case?
Like having 15 in that place.
No, 15 is deleted. 15 is
Yes, sir.
deleted. Yes.
Deleting 15 and not deleting 15, I mean, putting A in that place of 15 is same. It is not improving the case of fine. That's what I'm
No,
saying.
that is fine. That is fine. But why do you think that delayed reordering does not have any advantage?
And sir, delay means how much a delay? When will we reorder?
That is a design choice. Okay. So suppose you say that if n is the table size, okay, my design choice is such that whenever A is close to n by 2, I will reorder. Okay. Till that time, I'll not do any reordering, because every time I do a reordering, this will eat up additional time. Okay. Given that if the frequency of insertion and deletion is high, it's usually not so. But if the frequency of insertion and deletion is high, then every time you delete, you will have to do this reordering before you can proceed to further search. So let's say if my number of A's is close to, say, some n value. Okay, so basically what I'm trying to say is that if A is order n, at that time I'll try to reorder.
Okay.
I'll reorder the table size, not before that. So now if this is the situation, you have these A's placed in different places. Suppose you have a situation like this. And now you have to do some insertion. So we have already looked into the deletion. We have to do an insertion. Say insert the key and the object. Okay. So you start at HK and probe.
दबा दिया मैंने
Please mute yourself. Probe consecutive elements until, can you tell me what should be the scheme? A logical scheme?
Until A are a blank spaces.
until empty or A cell is found where the element could be stored. Okay. All N cells have been probed. No space through exception. Okay. So in the previous example, if I ask insert 3 and you are still working with key modulo 13, what should be the place?
Six.
So 3 is taken, 4 is taken, 5 is taken, 6 is available. So 3 gets inserted here. So now place all the things together. So insert, delete, find. These are happening in a pipeline. Okay. All these three together makes the full collision handling scheme. They are happening in conjunction with one another. Okay. So depending on the next action. So whenever it's an insert, you insert. Whenever it's a delete, you delete. But the assumption is that insert and delete, their frequency is far less than find. Okay, so this is an assumption. So this is roughly like an overall scheme that is followed in linear probing, which is like a subsegment of open addressing. So now there could be other methods of. What could be those? As I told you earlier, that rather than probing the next cell, probe the ith cell. Now question is, what is I? Okay. This could be the immediate question. If I say that do not probe the next cell, but probe some ith cell. So he will ask me like what would be a prescription or a heuristic to determine what is the ith cell. Now this ith cell determination is done using various schemes, something like a fixed increment, where you say that HIK is HK plus CI, where C is a constant. Okay. Or it could refer to some sort of a changing direction, where my HIK is HK plus CI because it's a circular notion. And an important one is double hashing, where you use two hash functions. HIK is equal to HK plus I H prime K, where H prime K is another hash function. That's why the name double hashing. Now, how do you go about doing this? Let's take the double hashing example. Typically, in double hashing, you identify something called a secondary hash function. Okay, so you have a primary hash function HK, and a secondary hash function, let's say DK. Okay, so your new hash function is HK plus J into DK modulo N, where J ranges from again between 0 and n minus 1, restricted by the table size. Okay, and n is prime. So let's take one example and see how double hashing would work on the same table of size 13. Let us assume n equals 13, HK is equal to K mod 13, and DK is equal to 7 minus K mod 7. Okay, this is how the two are defined. Say these are my keys. So what is my HK here? Let's quickly write down the HKs. This should be 5, right?
5. Yes.
2, 9, 5, 7, 6, 5, 8. What are my DKs?
3, 6,
3.
6.
No, not. Is it 6?
Okay, 1, sir. Sorry, sir. 1.
1. This is
6.
6, 5, 4, 3, 4, 4. Okay. Now the probes. So your J, if you recall, J is running from 0 onward. So the first probe is made at 5 plus 0 into 3. Okay. So that is 5. Right? So the J value is 0. You start from J, 0.
Sir, what is J here, sir?
We just now defined. HK plus J into DK. J is an arbitrary number starting from, sorry, an integer number starting from 0 and going up to n minus 1. So your function here is, the overall function here is fine. So we will probe as long as we don't find a location, available location. That's why I have written the word probes there.
Sir, can you please scroll down?
Yes, I'll do. So you will have to iteratively run through J in order to find out the location where you can put 18. Okay.
Okay.
And if there is a collision, J proceeds. So J is like a pointer. Okay. J is like a pointer that is proceeding. And you will have to iteratively move J as long as you find a suitable position or an empty position for the particular key to be entered. So in this case, 5 into 0, 5 plus, so that is HK plus 0 into DK. To start with, J's value is 0. So 0 into 3, that is 0 equal, so that is 5. So we check whether location 5 is empty or not. Indeed, it is empty. So we put 18 here. Okay.
So J is also going to vary circularly, right? Like after, if J equal to 12, then we need to probe. So it will again be 0.
Yes. Every time J restarts for each and every probe, again here J will restart. So here probe is, number of probes is 5. Okay. Now here what happens? It is 2 plus, again J starts. So J is a pointer that starts for each and every individual key separately. So this is 2. So 2 is available. So we put 2 here. So 2 probes, first, second.
Sir, 41, isn't it?
Yes.
Sir, I
Oh,
mean,
sorry.
in place of
Sorry. Yeah. I'm sorry. Okay, so there is a 0 also, which I missed. Yeah. So in place of 2, it will be 41. Now for this one, 9 plus This is 0 into 1. You did not correct me. Okay, 0 into dk. This is 9 plus 0 into 6. That is again 9. And 9 is available, right? So after 9 probes, 22 sits in the cell 9. What about 44?
It will go to 10.
Sir, it will go to
5.
10.
Yes. 5. First time, the first probe will be 5 plus 0 into 5. That is 5. But 5 is taken. Okay. So you go to 5, 5 is taken. Therefore, I vary j, and my next value of j is 1. 1 into 5, that is 10. Now I do 10 probes again, and I see that the cell is empty, and therefore 44 sits at 10. Okay. Next 59. 7 plus 0 into 4, that is 7. So 7 is available. So 59 sits at the place of 7. What about 32? 32 is 6 plus 0 into 3, that is 6. So 6 is available. 32 goes and sits at 6. What about 31? 5 plus 0 into 4, that is 5.
0.
5 is taken. Yes, very good. 5 is taken. 5 plus 1 into 4, that is 9. 9 is also taken. So then 5 plus 2 into 4, that is 13. Okay. So, and you already remember that everything is happening in modulo. So 13 means 0. Okay. So therefore 31 goes and sits at 0. And the probes are similarly for 73, the probe is 8 because 8 is already free. Okay, so this is how you select the, as I said, you select the ith cell. Rather than selecting the next cell, you select the ith cell. This only empirically guarantees, like depending on how well you choose your HK and DK, this only empirically guarantees that the numbers are spread better in the hash table and you minimize collisions. Okay? That is why these kind of heuristic techniques, these are all heuristics. These kind of heuristic techniques are adapted. Okay, so the rest of the lecture, we will try to motivate ourselves with a nice application of hash tables and hash technique and the hashing technique in general. Okay, so we will take up the problem of string matching. And let's see how this problem can be nicely solved as an application of hashing technique. So this algorithm that I'm going to talk about is due to Rabin and Karp. and therefore popularly known as the Rabin-Karp string matching. Okay, so the main idea here is that you want to find a pattern, let's say, find the presence of a pattern. Find the presence of a pattern, let's call M, in a sequence of characters. So you try to find the presence of a pattern M in a sequence of characters, which is typically called the string. Okay, so what do we do and how do we use the hashing technique in order to achieve this? Okay, so basically what you do is you compute the hash value of the pattern M, and you also compute the hash value of the next M character subsequence of the whole sequence. Okay, wrong English, from the whole sequence. So you do the hash value computation of the pattern that you need to search for. Let's call this pattern M. You compute the hash of M, and you also compute the hash of the next M characters in the sequence where you have to find them. Now you compare the two hashes. Can you tell me what should be the actions if hashes do not match and hashes match?
Sir, if hashes match, then we print yes.
Then you
Sir, we print yes. I mean, there is a
you
pattern.
print yes. You immediately print yes.
Yes, sir.
Recall, hashes have this problem of collision. Yes, yes.
Sir, if hashes do not match, then we can certainly say they are not same.
Absolutely. So hashes do not match. Proceed to the next mchar subsequence. This is what you wanted to tell, right?
Yes, sir.
Huh. But what about if hashes match?
We check if they are equal.
Yes. Here you do explicit character by character matching. So you see the trick this guy is playing. So why this was an interesting trick? So you like avoid a lot of character matching by just doing this kind of a intermediate hashing. Okay. So all those cases where the hashes don't match, and hash computation is typically faster than doing an explicit character by character matching. So that's why we will see how we make it fast. Okay, so that's why the authors, okay, this was a paper. So this was a scientific paper that was written long back. That's why Rabin and Karp actually came up with this very intriguing idea of computing hashes, and like which made them like fully sure that if the hashes did not match, then the patterns are not going to match at all. So let us proceed to the next subsequence. Only if the hashes match, then I have the headache of explicit comparison. So let us do some little bit of math in order to like set the stage for the full algorithm. So let us say that this m character sequence is an m digit number in some base b. Okay. Where of course b is the set of letters in the alphabet that you are considering. It might not be the English alphabet. I'm just calling some imaginary alphabet. So let us say the text subsequence that you have let us say this is represented by okay, and let the corresponding hash be a very similar function that we had already learned when we studied the polynomial hash. For the next subsequence, xi plus 1, this will be okay. Now, if you have to every time compute this, that's going to be cumbersome. So one easy way would be to look for a simple transformation that could be achieved if given xi, okay, given xi, what would be xi plus 1? If an estimate could be easily obtained, then if an iterative estimate could be easily obtained, then our job becomes much easier. Okay, otherwise every time we have to keep computing this. So can we do that? So can we express xi plus 1 in terms of xi?
Sir, xi into b, then we can add the last term and remove the first term.
Absolutely. Xi into b, and we remove the last term, right?
Sir, we should remove the modulo of the last. It can make the
We are
term.
yeah, we are not doing modulo so far. We will do. We will do. Don't worry. Everything will be modulo now. Okay. Now, as you have correctly pointed out, this b power m could be very large. Okay. B power m could be very large. This we have already discussed earlier also. So therefore, we will choose some prime number again. Let's call it q. Okay. And we will do all the arithmetic in modulo q. Okay. And I think all of you remember from your class 2 that there are some interesting properties of the modulo arithmetic system. Is equal to
X plus Y mod.
Sir, x plus y mod.
X plus y mod q.
is equal to
X mod q.
so now given this we have our hashes. So hi from xi
Sir, I think even finding b power m minus 1 should be recursively found by using mod.
we will check, we will write the code. Let's finish this. So this is how hi and hi plus 1 could be constructed. Now, once we have this, it becomes easy for us to write the pattern matching algorithm or the string matching algorithm. Sorry, we are mixing two things. Let's call the string as p and the length of the string as m. So what are we doing? What is going on here? What is going on here?
So we are finding
So
the
we are
hash
finding
value.
H0.
Hash value.
Yeah. And also the hash of the pattern. Okay. And then what is happening here? We are now moving subsequence by subsequence, right? We are moving subsequence by subsequence. Fine. And then every time we are updating the hash of the next subsequence using the formula that we have just now derived.
Sir,
Yes.
sir, are we storing the hash value into separate array?
Do we need to? Do we really need to? As soon as the hash is checked, we don't really need to store them anywhere. You either proceed or you make an explicit check.
Sir, in the last expression, sir, the brackets between TS and TS plus 1, are they right?
Huh?
Sir, the bracket
There is a
between
bracket here. Okay. There is a bracket here, and this bracket, sorry, so there is one extra bracket, I think, yeah. This one is for the modulo thing.
also, sir, why are you multiplying the whole term by h?
Tell me why.
So we should multiply TS plus 1 by h.
Okay, so dh is d to the minus 1 mod q. Okay. So ts plus 1 is this one. Okay, yes, you are correct. So it should be okay. Let us take an example.
Sir,
Simple
also
one.
there should be a bracket between TS, we are multiplying by small d there, because h is d raised to power m minus 1 only.
Yes, sir.
No, wait. What is TS? TS is dt0 ti. Okay. This is the ti minus 1 into the This is the Ti minus, sorry, Ti plus Ti into the dm part. Okay, and so it should be this, na?
No, sir. After H.
No, wait.
Sir, without putting brackets, it will be
Okay. Yes. So it should be like this. Just, I am making a mistake. To this and this.
Yes,
Ts
sir.
minus Ts plus 1 into H. This whole thing into D plus Ts plus 1.
And sir,
Because
should it
both.
be T of S plus 1 or T of S only?
Why? This is the next element. S plus M plus 1.
No, sir. Where we are subtracting. So we are subtracting the first element.
Yes.
So it
So
is
this
TS.
is this is just the same thing that we did earlier. And here the
Yes.
counting starts from 0. There the
So
counting was starting from 1.
okay, sir.
The mathematical calculation that we did, the assumption was that we were starting from 1. Here we are starting from 0.
Sir,
Huh?
sir, what is H?
Huh?
Sir, H. What is H?
What is H? H is defined here. Now the next question is, what is D? What is D?
the base we are calculating.
Yes. Okay, let us quickly do an example. I think the idea is pretty clear.
Sir,
Let's
D
say,
is directly the base or any choice of ours?
typically you choose a base.
Okay.
So here, say you are searching for the pattern cab. Okay, let's say my Q is set to 3, my base is 26. Okay, and we have 0 to 25 as the indexes of the characters. Okay. Now, what is hash of cab? A is 0, B is 1, C is 2, Z is 25. Two into 26 square plus 0 into 26 power 1 plus 1 into 26 power 0 modulo 3. This is position 2, this is position 0, this is position 1. Hence, it's coming here. Sorry.
Sir, previously you said that if we take the DS33, then it will be eliminating the collision.
Yes. This will reduce. I'll come to that. That's a very good point. I'll come to that. Let's see this example. Let's check this problem here. Here you will soon land into collisions if you take 26. That was the reason, right? Somebody said last day that why can we not take 26? We will see that here we will land up into collisions if we take 26. That is why I chose 26 here.
Okay, sir.
This is 2, this is 0, this is 1. So 2, 0, 1. So how much is this? This is 0. Now the first 3 characters
Sir,
hash.
sir, why do we choose the Q value so less? Because it does not reduce the spread. Like we only have 3 options, 0, 1 and 2. So there will be more collisions.
I don't understand. 0, 1 and 2 means?
I mean, since we are taking modulo 3 only, so the hash value can have only 3 options.
Yes, true.
So does not that reduce the spread too much?
You can choose anything, but even if you choose any other number, like so here hashing is not the main application, right? Here the pattern matching is the most important application. So that's why we have chosen some arbitrary Q. You could choose 5, you could choose 10, sorry, 11, you could choose some large number. That will of course spread things, but even then collisions cannot be avoided. And if you choose like the base number as we have chosen here, like 26, the bare minimum, then you have typically larger number of collisions than if you choose something like 33 or the other numbers that were suggested. That was the idea why I chose this. This is, as I said, a design choice. Sorry.
So 0 into 26.
No. This is A and B. This is 0 into 26. Okay. So this does not match. So we proceed. AB does not match. So we proceed with ABB. So this is something that I wanted to say, that this is something could have been avoided by choosing some other value of B or D, whatever the base, or in your, so base B or the parameter D in the pseudocode. In the pseudocode. Okay, so these explicit comparisons could have been reduced by a suitable choice or a suitably better choice. Okay, and of course, like as you have pointed out, it's not only this, but also the value of Q that could be chosen in order to increase the spread. Both are true. But even if you increase the spread, the judicious choice of this value B or D is still important. in order to reduce the possibility of collisions. And in this way you proceed, and the moment you come to the correct pattern, you will have a hash match, and then like the pattern will also match and you can flag a match. Okay. However, there could be multiple matches. That's also possible. So you should not stop here. You should keep on moving and report all the different matches. So this is how the string matching algorithm works. Okay, so we'll stop here. And Deepank, are you here?
Sir, Shrey, I'm here.
Sir, can you
Okay,
scroll?
Shrey. Okay. Oh, I thought it was Deepank. Yes.
Sir, in the hash
Sir, can you
matching,
scroll above
sir,
to the
To which place? Tell me. Which place should I
when
scroll?
you started the algorithm?
Started the algorithm here.
No, means when you started the topic string matching at that part.
Oh, started the topic. Okay.
So
Here.
here you wrote subsequence. I think it would be substring.
Okay. Like going by the strict definition, substring. Fine.
And sir, I had another doubt. If for string hashing the collisions are as less as 7 for 5,000, then can't we take the integers to be strings and do their hashing?
Integers are strings.
Yes,
What
sir.
does that mean?
Means we consider all the digits as characters.
And do a hashing.
Yeah, similar to this, taking a base.
No, that will not be so nice, because English words have a specific statistics. Okay. In fact, any language has a very specific statistics. Certain letters do not come after one another. So there are various interesting lexical patterns that are followed. Because of these lexical regularities, you see such interesting reduction in the number of collisions. This might not happen like when you take digits.
Okay, sir.
So remember, that was for English words only, dictionary words.
Sir, in the worst case, sir, it may happen that all the hash values collides with the.
Yeah, that is always possible. The worst case is always possible. All the hash values. So that's why we tried to design this polynomial hash function, no, so that it reduces that chance. That's why the choice of base is very important.
Sir, can you go to all governments, where you wrote this algorithm?
The coding, the code part.
Yes, sir. Sir, here I didn't get, should we take T of S plus 2 or T of S plus M plus 2? We shall go to the next immediate character.
And how is M changing?
Sir?
Huh?
Sir, I didn't get what you asked.
So like what is the value of M here?
3, like the length of sequence.
The length of the sequence, right?
Yes, sir.
So the length of the pattern, sequence. It's not the length of the full sequence, it's the pattern that you are finding.
Yes, sir.
So you compute yourself. You compute yourself and find out why it should be so. We just now saw this, right? In the
Okay, sir.
previous, in the mathematics, we just now saw this, why this should be m. So this is a replica of this expression. Okay, Shrey, you can start. I'll
So I
stop
need
sharing.
permission to.
Yeah,
Sure.
I'll do all that. I'll stop sharing now. You are a presenter now.
Yes, sir. Is my screen visible?
Yes.
Yeah, okay. So, hello everyone. My name is Shrey Shrivastava. I'm a fifth year undergraduate in the Department of Computer Science and Engineering. Today I will be talking about C++. So, yeah. Like I have assumed that most of you know C, and this is just an introduction to key concepts that will help you dive into the bigger story. We are constrained on time, so I will mostly be dropping some names and so that you can search for yourself, and I will explain some things. So, just wanted to know how many of you actually know about classes and objects. Like, can you raise your hand? Okay. Yeah, so like some of you do, others I don't know. So basically, if you go by the classical definition, when we're taught classes and objects in our, like some of you might have studied them in class 11, 12th. So we are talked about like it helps in, encapsulation of variables and methods. For example, if you have a class which is associated with a cube, so you might have the size of an edge, and then you might have associated functions which can calculate its volume, surface area, and other things. So this is a way of storing code, organizing it so that it can better be manipulated. So, but I'll talk about some other things that are more important. So one way to write code is like data oriented. You have some input data, you declare associated variables and functions, and you just call functions on that input data. So this is mostly what you have been doing up till now in your C codes or the algorithms that you do. But when you write big codes, like which has 10,000 files in each with 10,000 lines of code for big softwares, you want some form of organization of code so that it facilitates reusability. And just like functions help organize lines of code, classes and objects helps to uh, find that organization at a higher hierarchy. Okay. So this is a simple sample code of what a class may look like. So I'll just first talk about the obvious things. So you have this class algorithms. So the name of the class is algorithms. Uh, if you have used structures in C, this is almost similar, except for access modifiers or access specifiers as mentioned here. So I'll talk about this, but I'll just go through the class definition once. So you have this variable string m name. So you have a variable of type string, which is member name, and we'll use this in our functions. So we have a function set name, which just takes a variable name and sets it to m name. We have another which is getName, which can just return mName. And we have printName, which doesn't takes any variable, but just prints the name that we have as our uh, class variable. Okay, so what is public and what is this access specifier? So basically, C++ gives you functionality to hold some of its data private, or like so that it cannot be accessed from outside the class definition. So what is the class definition? So you see this, the class starts after algorithms at it, like this thing is class definition. So I'll just go to the next slide. So this is how you use a class. Just like you would declare an integer variable, you can declare a object of class algorithms or algo object, and then you can call the public methods on this object. So set name, get name, and print name are under the access specifier public. So they can be accessed from outside the class definition, such as by declaring an object and calling that function. But uh, string mName is under the private access specifier. When we don't mention an access specifier, it's by default private. So if I would have done something like just printf and I would have said algo object dot mName, then that would have not worked. That would have given me a compiler error because I have declared it as private. So I request you to take this example and try out some more variations of what you think would work and not work based on this definition that I just mentioned. So like in this example, when I do algo object.printName, I'm not even passing what do I want to print, but because that method is associated with my object, it takes in that mName from the class definition itself and prints it. Does anybody have it? Yeah.
So, but can't the same thing be implemented using structures?
Yeah, I mean, but can you do that private and public thing? I mean, in C you can't, but like not. Can you do
So,
that
sir,
private
apart
and
from
public?
that private and public, that thing is there any difference?
Yeah, that is the main difference. I mean, this idea of abstracting some information from the user, I mean by user I mean the programmer, that language wants to restrict the usage of some variables and some methods. So we have this special ability in classes. Yeah, I mean that is the major difference.
Sir, we can explicitly define private members in a struct as well, right?
Okay, so if you can, there are other things also. For example, when you go deeper into classes, there are things like virtual functions, there are things like friend functions in which you can. So structure is the way structure came into existence in C. It was defined for a very simple purpose that, okay, I want some data types that I need to be that I want to be coupled into a single structure. But the way classes was formulated, it was like thought of as a bigger thing. So I'll just take some names so that you can search for them. So you can look up for what are friend functions and what are virtual functions. Like these things you can't do them in C, but you can take you can have them in classes in C++. So these are some of the things, but like you'll have to study a bit more to really understand what they are doing and how they are working.
Sir?
Yeah.
Sir, here, how are we encapsulating the data? We can always scroll up and see what are there in that class.
Can you come again?
Like here, we cannot do algo object dot s1 equal to that name.
Yeah,
right?
yeah. You cannot do algo object dot mName equals to this name. Like
yes, sir.
Yeah,
But
you can't do that.
Here we say that this is data encapsulation. That means we
Yeah,
cannot
yeah.
directly use the variable.
No, data encapsulation means that you have encapsulated. Like the word encapsulated means that you are grouping something. So the quality of grouping variables and methods into one single piece of code is encapsulation. and that hiding thing is called abstraction. Yeah, so you can continue now.
Yeah, not
Yeah,
really
yeah.
private. Like we can see, I mean, we can go through the code and see what variables are there.
Okay, okay. You're saying that okay. I have like the class definition. In that I have already declared mname. So what I can do is like once I define it, like uh, uh, once again, can you repeat your question again?
So here we are saying that we are declaring the private variables, right?
Yeah, yeah. Mname is a private variable.
So that we cannot use dot that variable,
Yeah,
like
yeah, yeah.
algo.
Yeah.
But here, what is the necessity of that privateness? Like we can go through the code and see what is that variable.
Okay. Yeah, so basically, it might happen that sometimes you just accidentally change that variable in your code. I mean, if I just give you access to that variable, so here what we are doing is like using set name, you can change it, right? But what if I declare it as a constant? Now, when I declare it as a constant and I just set it, so if I have that variable, right, I can change it. But the next time I call set name, I don't want to change it at all. Like the first, so it allows you to have this functionality. Like you can, so once it has been declared private, you can't change it. Also, like you'll learn about um, how you can use inheritance. Inheritance is a way of declaring classes which are derived from higher classes. In that, if you like, you can declare a variable that you don't want any of the objects to have access to. I mean, uh, yeah, let's take this example. So you have declared a private variable which is pi, and you have said that okay, the value of pi is 3.14, and I don't want it to be changed accidentally by the programmer. So I have declared it as private, and I'm using it in my class
Sir?
definition for calculating. Yeah, yeah, yeah.
Sir, your voice is actually breaking.
Okay. Is it the same for everyone? Like, is my voice breaking for everyone?
Not for me.
No, sir.
No, sir, it's not breaking.
No,
No,
sir.
sir.
From me.
So maybe it's something in some internet issue on your side. So I'll continue.
Sir,
Okay.
can you please increase your voice a little?
Uh, okay. Um, yeah, like I'll try to speak louder. Like, is it better? I mean, it's no real way to increase my voice. You can have a speaker which has a higher volume output. But
No, sir,
I'll
I
st
thought it may not be at maximum volume.
okay, so I'll try to speak louder. Okay. So, um, yeah, where was I? Yeah, I was giving the example of pi in which you can declare it as a private variable. So there are other examples in which like you can see the utility of why private variables are important. And like they like you can think of them as variables that you once defined at the starting of your initialization of object. You don't want it to be changed going further. Any like it might have like you don't want to accidentally change it, or you don't like this might have like I'll give you another example. So you as the first programmer write a code in which you have declared a variable which was private, and you develop it as a library. Now you pass that library in open source, and now you want that people use it. So during some other programmer B who uses that library, he's trying to get a functionality working, and he sees that okay, I have this variable. If I manipulate this, so this functionality starts working. But then he realizes that okay, uh, but what it does in the back of the picture, it spoils some other functionality because that private variable has something else to do with some other functionality. But because the programmer has no information of the entire library, he just uses it and like um, he spoils that he uses one functionality, he spoils that functionality. When he gets to that functionality in the future, he has no idea why things are not working. So there are other examples why you would want some variable to be private, and you would like to restrict the programmer to have access to certain functions and method variables, and not have access to other functions and variables.
So, sir, all these will be in some header or some library which we
Yeah.
cannot see directly.
No. So you define a class definition. You will be responsible. So you can have a class in a file, and then you can import that class definition inside your code using a file, or you can just have a single file in which you define the class definition and you have the main code, the main function. So you can do it any way you want. You are the one who will be defining it.
And sir, can we define constant value like constant pi equal some constant?
Yeah. So there is a keyword called constant expression. You can search it, and this is how like one way is to define it as integer, right? You can say that int PIE is equals to 3.14, but then the compiler treats it as a variable. But you want that compiler understands that it is a constant and you don't want to change it going further. So you can declare it as constant expression. Like you can have that keyword in front of it, and the compiler understands that okay, it's a constant and it doesn't has to be changed in the span of the program.
Okay.
Yeah. So next we are going to talk about containers. So the word containers is basically you have known data structures, right? You know about trees, you know about heaps, you know about um, balanced binary search trees and other things. So containers are basically an abstraction of those data structures, and they provide you functionality for insert, erase. So the important things. I mean, the implementation of a data structure for insert, erase, and it might be different, but you can have a uniform way of accessing that, right? Like that functionality. You can have like insert, erase, and other things for. So that is how we define a container. Okay. So now containers in C and C++. So I mean, C only provides array as a container. I mean, does anybody know any other container that C provides? Like inherently, like you can implement other things on the top of it using pointers and variables, but does C provide any other container? Yeah, I mean, I don't think it does. So when you like going forward in your fifth and sixth semester, you'll read more about memory organization, like how is memory organized in a computer, and you'll see one thing that array is the only container which comes with zero overhead. So when you are making a value in an array 0, 1, 2, 3, you are essentially just taking that associated set of bits and you are setting it or not setting it based on whatever data you have. So for example, your character would be 1 byte. So you take 1 byte of data and you set that with the associated value. For integer, which is 4 bytes, you just take that and set it. And it is contiguous, right? In an array, the memory is contiguous. So if you want to think in terms of pointer, you are just returned an address of that memory that you can use. So that is there. So, but what is the problem with this? So this comes at high risk because now it is programmers' responsibility to ensure that they don't access memory outside the allocated region. Like, can someone tell what happens when you do that? When you access memory outside the allocated region?
Segmentation fault.
Yeah, exactly. Exactly. A segmentation fault is thrown by the operating system, and you are stuck with like, okay, what do I do now? So this is the risk, but there is a high reward. Like arrays are insanely fast. I mean, programmers who work close to the hardware, like who care about like 1 nanosecond of latency, they use C, and others even code in assembly. So assembly language is even faster, it's even closer to the hardware. You will learn about that in your 5th semester compilers course, so that is there. But I don't think most of us as programmers really care about 1 nanosecond of latency. What we really care about that programmers and fellow programmers really understand our code and they get some idea when they see our code, like what we are trying to do. So STL is like basically a set of um, predefined functions or capabilities that help you safeguard yourself from errors. But this error checking comes at a cost, and that is why it is a bit slower than uh, C. Like C is very close to hardware, it's very fast. C++ is a bit higher, but it is a bit slower, not that much that it really bothers us. So STL containers are basically of two types. They are sequence and associative. So when you think of containers, you usually think of sequence containers like array. So in the same line of containers, we have vectors. I'll talk more about in the next slide. List is basically the linked list. We call it list in C++. So you declare nodes which have individual set of memories, and then you just associate them using pointers. And then you have PQ. One second. Yeah. So these containers are classes as well, which abstract the underlying data structure. Like, does anybody gets an idea what I'm talking about here? Like these containers are also like vector, list, and dequeue are also implemented at classes, and they have an underlying data structure. Just like my algorithms class had a string data structure inside itself, these vector, list, and dequeue also have an underlying data structure. So what I'm talking about. I mean, it's not like difficult.
Vector
So
is
for
itself the class, so vector name will be object like that.
uh, not like that. Like you have implemented stacks, right? So in stack, there was one way that you had this underlying data structure, which was actually a linked list node, and you create this abstract data structure, which is stack, in which you can do a, a push and a pop, right? So it's basically a linked list in the background, but you actually use it as a stack, right? So this is what abstraction you're trying to create using an underlying data structure, so that it fulfills the purpose of a stack, but it's actually a linked list in the background. So this is what we implement using class in C++ for vector, list, and dequeue. And you'll have these public methods in which public methods that can be accessed from outside the class definition as insert, erase, clear, that are available to make changes. Okay. And here you can see that those uh, underlying data structures, for example, I'll talk in vector mode, like that will be private. You'll only have these public methods to make any changes to it, so that you don't spoil the internal state of the data structure. We'll talk more about this. So next in the line is associative containers. So in sequence, like programmers define the sequence of elements. In associative containers, like containers control the sequence of elements in the container. So what I mean by that is, so just tell you the example. So we have these containers map, set, multi-map, multi-sets for which are associative containers, and they have this key value pair through which you can access these elements. Similar to vector, list, and dequeue, which are sequence containers, they are also implemented at classes, and we'll see what is the underlying data structure and get an idea of how these things work. So firstly, vector. So just like you define a integer array, so you say like int, and then you define the variable name and you define the size. Similarly, you can have a vector t. T is the type name. So example vector int, and A would be an array of integers. The underlying data structure, like very obvious, it is an array and is implemented using a class. So yeah, the first important thing, you don't have to declare the size during initialization. I mean, whenever you have declared array, you always had the size. It may be like you directly declare it as a constant value 100, size 100, or you took in a variable of size C using scanf or something, and then you declared it using that variable. But you don't have to declare a size. So any ideas how this might work in a class setting? Like what we might be doing in the background so that we don't have to explicitly tell the size, but still it works?
I think linked lists are used.
No. Linked lists are very slow. I mean, the problem with linked list is like you declare memory for one node, and there is no way to ensure that those memories are all contiguous. And when there is no contiguous memory, you can assume that the code is going to be slow. So we don't do linked list.
We have a default size mentioned in the class.
Yeah, somewhat like that. So we say that okay, we take a size like say 100, uh, not the one that C++ uses, but for an example, we say that okay, I'm whenever a vector int a is defined without a size, I'm going to declare it of size 100, and and like what happens next, like we'll talk. So we have some member methods, which have the first one is pushback. So you have some array. So for example, you have two elements, 1 and 2, and you again want to push back an element 1. So if you had an array of size 3, it would have been very easy, right? You took the third index and you had assigned it 1. But now that I'm saying that I have a vector of size 2 and I just want to push back 1, so what do I do? So like we have discussed, we have actually declared a array of much higher length. Like we have declared an array of size 100, and we have kept another variable in our class, like another private variable called size, through which we are storing the size of the current vector. So that must be 2, and then we accordingly assign 1 to that particular element. But do you see a problem with this? Like when is it going to be a problem? Like I keep on pushbacking, like I do it for like 1,000 times. Will it cause a problem?
When we
So
reach
it
the
will
end,
be larger than the size allocated by C++.
Yeah. That is a problem. So like now that we know the problem, can you talk about the complexity of pushback? Like when we insert at the end of the array. So like the obvious thing, like once that memory gets exhausted, like size 100 memory gets exhausted, we have to assign more memory, right? We have to assign more memory to the vector. So there will be obviously a complexity uh, consequence on that operation pushback. So can you talk about like what might be the complexity of pushback?
O of 1.
Yeah, O of 1,
or
but
worst case, when the size of the array get exhausted,
so
because we need to
I'll
copy the new array.
yeah. Actually, O of n worst case, O of 1 like a constant, but I'll say you both are partially wrong. So any other answers?
Over all operations, it's ON.
Over all operations, it is O1 actually. So basically, uh, because we already know that we are going to face a problem, we do something interesting. What we do is like we allocate the memory as powers of 2s. So what happens is uh, like first we allocate a memory of size 2, then we do it for 4, then we do 8, then we when it gets exhausted we do 16. Similarly, we keep on making it as a power of 2. But if you do the complexity analysis, then you'll see that it actually comes as amortized O of 1. Like it is constant time, but it is amortized over all the operations that you do. So a single operation maybe in worst case be O of n, but over all the pushbacks that you might do in a program, it is amortized. So you can search more about it, like how does it actually is implemented in, and like it's up to you for your interest. So next member method is like insert. So you want to insert one at the beginning of the vector. Like, what will be the complexity?
O of n.
Yeah, true. I mean, the same problem, right? That like what I'm doing, and it's actually a data structure is array, and I've already assigned values to it. And now that I want one to be in the beginning, I have to shift all the elements of that array one step forward, and then I can have the space for the first element. So O of n is the complexity. Similarly, you have pop back. Pop back is simply reducing the size. You have erase. Erase is again like it can be worst case on, and size is just it returns a private variable size. So like the idea that I want to give is like you should
Sir,
understand that.
you said pop
Yeah.
back has worst case complexity order n.
No, erase. Erase is O of n. Pop back is like just reduce the size one.
Okay.
Yeah. Yeah, so the idea that I want to give you is like how things are implemented using classes. What variables should we keep private? What should we give access to the programmer? And how all of those work under the background. Like these things work. Now that we have talked about vector, like I'll talk about some algorithms. Like you might have used some sort of sorting algorithm like comparison sort, merge sort, quick sort, insertion sort, and other things, right? So instead of implementing it, you can just call sort a dot begin and a dot end. So a dot begin and a dot end are like iterators. I'll talk more about it. So it returns, they are just like pointers, but they are also wrapped in like classes so that they become smart. I'll talk what I mean by smart. So you just tell the sort function that, okay, this is the beginning vector of my array, this is the ending vector of my array, and just sort it. Like I don't even tell it like, okay, this is of char type or integer type, and this might have like 4 bytes of data, so you must need to take care of that. I don't have to tell it anything, irrespective of what is the internal data of A. I can just call this function and I can expect it to return the right thing to me. So this is what classes allow you to do. I mean, can anybody tell me how you can do this in C without any?
Sir, if it is not
Yeah.
a vector, then can we pass the pointers as a and a plus n?
Yeah, you can do that.
So can we allocate specific memory location?
Like for what?
Like for
This is
pushback.
another very beautiful thing about vector as classes is you don't have to take care of memory. You just declare it that object, and like we'll talk how it manages the memory, but you don't have to declare any memory. Yeah, like back to your question. What was your question?
Like in pushback, when we allocate a new block of memory, how do you ensure that it is contiguous with the first block?
Exactly. You don't have to care about it. You just have to call pushback, and the language takes care of all of those things. In C++ makes the life much easier.
Then what if we just allocate one at a time rather than doing it in powers of 2?
Yeah.
It will be still O1.
No. So whenever you call malloc function, like it might happen that like this is like you'll learn more about this in operating system. It will be in your 6th semester. So whenever you want to allocate memory, it makes a system call to operating system and it asks for some portion of the RAM. So you see all of this, where is that code working? This is in RAM, right? You're like, how many of you know about RAM? What is RAM? Okay, nobody knows what is RAM. How many of you have played GTA Vice City? Like, you might have played a game and then it just hangs. Like, I remember playing GTA Vice City on Pentium 4 with 256 MB RAM, and like, it won't just, like, my screen would just halt and it won't move forward. So, so some of you have. So, basically, RAM is the area where your process resides and works. So based on the size of your RAM, the operating system can allocate you some memory so that your process can have it. Every time you do a function call to allocate some memory, it is going to take some time. And I can just tell you that it is a lot of time with respect to the other things that you might do. For example, if you just do an operation like a equals to a plus 1, and instead if you do malloc some integer array of size 100, that is going to take a lot more time than a simple operation. So you want to reduce the number of requests that you make for memory allocation.
Then linked lists are very slow as
Very
compared to
bad,
it.
very bad. Like we want to avoid using linked list as much as possible.
Okay.
Yeah. So, so the next algorithm is this lower bound. You can pass the begin iterator, end iterator, and you can do the value. So it basically does binary search. There is another like the opposite of it, upper bound, and there are a lot more SQL algorithms that you can simply call on the vector array, like vector, and you can have the associated result. So I request you all to look into this and like see what you can do with it.
Sir, I have a doubt.
Yeah, yeah.
Sir, we define vector, then within those greater than less than sign, we put the type.
Yeah, yeah, yeah.
What does that sign mean? Like less than greater than sign?
Yeah, so it's basically a way of telling the, so in integer, when you, how do you define an array of type characters? You say char array and then you make that square braces, right?
Yeah,
It's
like
this,
I mean, vector is a class, right?
yeah, yeah, yeah.
Then
So this,
like we have never used that syntax that less than
so
greater
this
than
is
sign.
called template type names. So you can search about this template type names. Like it will give you an idea of what those triangular braces are actually do. So you can have like,
Like
yeah, yeah.
is it like the generic classes of Java?
Yeah, exactly, exactly. You can have generic classes and you don't actually tell the type of the variable that you have inside it, and you can do it dynamically using this. So you say vector int. So I have a
Whenever we
type
write,
name.
whenever we
Yeah,
write the class, we write once for all the operators. Means all the data
exactly,
types. And
exactly,
whenever we
exactly.
provide that,
Perfect.
it will do it.
Great. Yeah, yeah. Okay. So next is like an associative container map. So like you can think of a map as a mapping, right? Like there is a key of type T1 and there is a value of type T2. So you can have a map of like from integer to strings that can store, for example, your roll number to your name. So this would be map. So I'm telling you that it is the underlying data structure is a BBST. Like you all have studied this, right? You have studied balanced binary search trees, right?
Yes, sir. ABL
Yes,
trees.
sir.
AVL trees, right? Yeah. So this is the underlying data structure. Now I'm going to tell you what all public methods are available for it, and you have to tell me how it might be implemented in the background. So I have a BBST over all the keys. Keys is like the first element. So for the example map, which is integer to strings, I have some integer values that are the keys for my balanced binary search tree. So how can I get the keys in sorted order?
In order trapezoid.
In order.
Yeah, okay. So this is what iterator does, right? So you can have an iterator. So now that you know how to get keys in sorted order, you search like iterator. Like so, uh, we you all already know what are pointers. So iterators are basically the same thing, but they have been modified to be used in C++ along with classes. So in iterator, when you increment a pointer, like when you increment a pointer, the compiler tells it like what is the size of a node, and it gets to the next value, right? Like if you have declared an array of integers, and like you use it pointers and you do like array +1, then you bracket and then you do star. So the compiler understands that okay, you want to access the first element of the array. Iterator does something similar. You can also like do plus plus with iterators and all other kinds of things to get that uh, um, um, those values of the nodes over the map. So you should look into that. Then we have insert. Like how can we insert a key value in the container and like what will be its complexity?
Insertion in a balance binary search tree in log n.
Yeah, exactly. Same. And how will you do an erase? So erase is the same as delete. Yeah, login. It will be login. So you see I have written all nodes with this key. So uh, there are two types of options that these containers provide you. Set and map, like they explicitly tell that okay, you can have only unique keys, right? But there are multi-set and multi-map which allow keys to be same in the container. So yeah, first I'll talk about set. So set are the same things that we have in maths, like you can define a set of integers, so it will only store unique integers that you inserted into it. For example, if you insert 1, 1, 2, 2, 3, 3, so it will only store 1, 2, 3, 3 elements. Similarly, if you have map and you do like 1 maps to name A, B map, 2 maps to name B, then again you say 2 maps to name C, so it will just override the last with the last insertion. But we have multi-set and multi-map which also allow the same key. So if you do in a multi-set, you do insert 1, insert 1, insert 2, insert 2. So the actual size of it would be 4, like with 2 ones and 2 twos. So how do we handle the same keys in, like what changes do we do in BBST for this?
So instead of each node of BBST, we store a linked list at each node.
Yeah, like
Like
yeah,
it's
like
pulling.
the idea is that now that we have keys which are not unique, we need to make some changes to our BBST so that we can have that possibility of storing unique or non-unique keys.
So we can
So
store a count variable at each node.
Yes, sir.
uh,
A count at each node.
that would work for set, but that might not work for multimap, right? Because I need to store the value as well, right?
Yes, sir.
Yes.
There is one, like there is another way, like you can have the same key. Like what is the big problem? Like you can have the same key, you search it at a node. If it is not there, you go to the left side and you search it in one of the grandchildren. Is that also an option? Do you think there is a problem with it? Like it's like I can say that, right? I mean, my BBST is, what does it say? That the lower one goes to the left side, the greater one goes to the right side. So I'm saying that okay, instead of the lower, let's make it less than equal to and throw them on the left side, and then it will, like, because it will be greater, so it will become one of the uh, grandchildren. I don't know which level, but it will become the right child of the grandchild for that node. Can I do that? Okay, so you guys search it. I mean, what, like whether it is right or wrong.
He says same, then what do we search?
What?
If key says same, then what actually will we search in the map?
Yeah, you search for the key, and like when you search for the key, all the values from the that particular key should be returned. So instead of just returning one value, you should return all the values. Like I'm talking with reference to a multi-map. So if I have like I have a multi-map from roll number to names. So I have the same name for two roll numbers. This is a bad example, like same roll number for two names, but let's assume that. and then I want that, okay, you return me all the names which have same roll number. That could be an example, right? I mean, when would I need that? So yeah, one easier way to do is like you do linked list. Like for every key you store all the values, but yeah. So next we have pass by reference and values. So this is very easy. I mean, like you already know pointers, so I'm just telling you uh, like C++ makes sure that you don't have to use pointers ever again, because most of us don't know how to use pointers, and even when we do, when we write code with pointers, we do pointer, then pointer to pointer, and then pointer to pointer to pointer, and like the other person who starts reading your code has no idea what you're doing. So references basically work as a single pointer. So I'll just read what this example is. So int x equals to 1, you pass it by value, it goes into that function, you increment it by 1, you print it. Cout is basically printing. So I've commented the output. So pass by value gives 2 when you printed. Makes sense, you passed 1, you incremented it, and you got 2. Then you again printed outside the function, you get 1. It makes sense, you passed it by value. Then there is no need for that change in the function to stay when it comes out of the function. But now you pass it by reference, it goes inside the function, you increment it, you print it, you get 2, you come out of that function, it stays 2. So this is basically a use case of how you can use pass by reference. You can see that ampersand sign in pass by reference function parameter. So like this is how you use pass by reference. So any idea how we might be implementing this?
Check the memory
Hello?
location.
Yeah, so like whenever you do ampersand of some variable, it returns the associated memory address. So it's somewhat similar, like we have some pointers working in the background and doing the things for us. So like if anybody is interested, they can search more about like how L values work and how R values work in C++. I'll tell you some links in which you can search it in the end of the presentation. So yeah, like this is a piece of code. Like it will set the background for how smart pointers are important for us. So like I'll go through the code and I'll try to explain what we are trying to do in this, but why it won't work. Then like so we declare a character array in capital that is of size 100, and then we have a input variable in small and length, and we capitalize it, and then we return in capital. Does anybody see any problem in this?
More than 100.
Okay, that is there. Anything else?
Or if it is
If it is
already
not,
capital.
if it is not a small letter, if it is
Yeah,
a
yeah.
number,
Yeah, true. That is also there. Anything else?
Returning char but asking char star.
No,
So it
that
should
is
be
fine.
at last in capital len equal to \0.
Yeah, that is also there. Okay, this is something that I did mistake. So yeah, that is true. But like
So
there
we
is
will not
something
get
else.
that.
We are returning the
So we will not get
returning the address of a
that
local
values
variable.
Exactly. Like
that will.
yeah, like
someone said
we
that
put
we are returning the address of a local variable, and that is the only right answer. So what like how many of you know about stack frames and like how does function calling works? Yeah, like I know it's taught in PDS, so like
yeah,
at
like
least we go.
when
Yeah,
in
yeah.
with like for example the main function will be called first, then after that if main calls something, then that function goes on top, like in a stack that function goes on top. Then whenever
Yeah.
that function completes the operation, then it will get out of the stack, then it will return the value.
Yeah. Like somewhat like this. Yeah.
Are DL there.
Yeah. So what happens is like whenever a function gets called, some memory is so you need to you'll learn more about it when you get into higher courses. But I'll just give you a brief of what it is. So whenever a function gets called, uh, some memory is allocated on the stack memory. So there are two types of memory in a process: heap memory and stack memory. Whenever you call a function, some memory gets allocated in the stack, and all the associated variables gets allocated in that stack. So this character in capital array will also get allocated on the stack. So you did all the things with it, and when you return that memory, so when the function ends, the stack is deleted. Like everything in it, from the official C++ documentation, the status of that variable in capital here would be undefined. For some, it might just work because operating system didn't touch that memory and it was just like that, so it might work. For others, it might just not work. So the status of in capital is undefined. Yeah. Go on.
Sir, why does the same thing work if we declare with a malloc, right? If we declare the
Yeah.
array with malloc, then it will work.
Yeah, I'll talk more about it in the next slide. So just to complete what I was saying, so the status of in capital variable once the stack gets deleted after the function ends is undefined, and you cannot the language doesn't guarantees that in capital would contain all the things that it initially had while it was in the function frame. Okay, so now we have convert to capital and we do malloc. So what does malloc do? Like anybody knows what exactly malloc does?
Take memory out of heap.
That it remains until we exit control.
Your voice is breaking. Can you repeat?
It just from a heap, and that remains till
Yeah, exactly.
It doesn't.
Yeah, so basically when you do malloc, instead of allocating that memory on the stack, the allocation happens on the heap. And the thing with heap memory is it stays like that until and unless either you delete it or the program ends. So because we are allocating that memory on heap, this is going to stay even after the function ends. And we can be very sure that whatever we expected in capital to hold in that variable, it's going to be there even after the function ends and you return that variable. So does anybody sees any problem in this? Like, or is this okay?
Sorry, it should be len plus 1.
Yeah, no, that is not the problem.
So sir, this will be deleted.
No, that is also not the problem. So basically we don't free that memory, right? I mean, I'm allocating it, but I'm not releasing that memory. So what we are doing is like we have a character array that is allocated on the heap inside the function, and that memory will live on even after the function exits. So uh, but we have to release that memory, right? I mean, let's say this function gets called uh, let's say 10,000 times, and we have every time the length is like 100. So you declare a character array of length 100, that is 100 bytes, and you call it like for 10,000 times. So this is like 10 to the power 7 bytes, like that is like 10 MB. So you are for like 10 MB is a lot of memory for a process. I mean, it is a lot of memory. So we can't just give away memory. We need to deallocate it once we have, when the purpose has been successfully completed. So how do you delete this? How do you delete this memory? I mean, you can't delete it in the function because you're planning to return it, right?
So we delete in the main.
Yeah, okay, you can do that. So you decide to, okay, I want to delete it in the main. But what if it does an early return and like this function is not so simple, and what like this whether or not you return in capital with so yeah, take this example. Before allocating in capital with some len, you do a error checking whether len is actually greater than 0 or not, and for some reason you passed len to be negative, and you checked, and instead of allocating memory, you just passed a null point, returned a null value in capital. So now you can't delete it, and if you do delete a null pointer, the system is going to throw an exception. So what do you do then?
We can use the same pointer again and again.
How? Same pointer again?
Sir, after the purpose has been completed, we pass the pointer
In the function. Yeah, so basically what you're talking is like along with the input, I also pass the output, like the memory that I need for the output, right?
Yes, sir.
Yeah, that is a way. Like I think it should work. But like I don't want to do it like that. I want to stick to the function, like that abstraction, right? I mean, I pass the input, I gets returned the output. That is what I want. I mean, that is a way, like you can do it like that. Also, yeah, like there can be some problem, like instead of just the simple example, you have like like you don't actually know what is the size of the output array. Like what will be the size of the output array that has to be returned, and like there is no way for you to know it like before calling the function. What do you do then? Like,
So realloc?
Yeah, that. Yeah, so you see that like there would be a lot of if and else, and then you have to do a lot of things, and like things become difficult. Like there is a problem, and like we are trying to find like just jugaad solutions for them, but there is no elegant way of doing it with the existing methodologies. So yeah, the solution is smart pointers. Like, so I'll just read it, like we come up with smart pointers where the ownership of a heap allocated object is with a stack allocated object, so that when the destructor gets called, the deallocation of dynamic memory can be done. So I have taken, I think, two names that you don't know. So first one is smart pointers itself, and the other is destructor. So anybody knows what is a destructor in class?
It is the reverse of a constructor. Like
Yeah.
constructor creates a variable, destructor, and the class is like we delete the class instance pointer, then it will remove all the data. Means
Yeah. So uh, I'll just talk it with reference to a class definition. So this is an example class definition. It's not the original one that exists in C++, but it serves our purpose. So I'll take this example. So uh, just like we had algorithms class, we have the smart pointers class, and it has a template class T. So it makes it independent of the type that we pass it. So we have this private variable t star m pointer, and we have this public methods smart pointers, which has the exact same name as the class smart pointers, and we have another function which is smart pointers, but it has a tilde in front of it. So the first function on the top is a constructor, and the below one is a destructor. So these are very simple functions. What basically happens is whenever an object is created of this particular class, the constructor function gets called by itself. Okay, so whenever an object is created, this smart pointers, the function on the top, will get called by itself, and you don't have to do anything. So for example, here in the main, in the third line, what you're when you declare that in capital, so even though like we are not passing anything, but yeah, so in the top function I have done. So in the convert to capital function, what I'm doing is I create a variable of unique pointer. So this is the actual implementation of smart pointers in C++. Unique pointers, I say that it is of type character array, and the variable name is in capital, and you assign some memory to it. So basically what new does is it's same as malloc. It will return a pointer to this block of memory that is of size len and has a type character. So when the smart pointer gets called, can you see my cursor?
Yes, sir.
Yes, sir.
Yeah, so basically when this way of constructing says that okay, whatever pointer this is called, if the default value is null pointer, so if I don't pass anything, assign it to be null pointer. So otherwise, if there is a pointer that is a chunk of memory, you assign that memory to this variable m pointer. Okay, so m pointer, what is m pointer? This is the member pointer, which is the private variable of the class. So whenever I call this, create this object and I pass a m pointer, so this pointer gets assigned to the private variable by itself. So this is the function that gets called whenever object of the class is defined. Similar way, whenever the objects gets destructed, this delete m pointer will get called and the memory will be deleted by itself, and I don't have to call delete m pointer by myself. So you see, this is the type of extra functionalities that class offers you. So
Sorry,
just go, yeah. Do you have a doubt?
Yes. In
Yeah.
the smart pointer, you put some colon. That notation I don't.
Where?
In the smart pointer, t star ptr equal to null.
Yeah. What about it?
Sir, is there any extra parenthesis that came, or is it correct?
Yeah, this is the right way. Like, yeah, this might be a new way of calling functions for you. Like, you are assigning the value of pointer to m pointer in the same line as your class variable. But this is a legitimate way of doing it, and like the way we do it is like it has to do with compiler optimizations. Like, if you define it in one line, then the compiler is smart enough to understand and doesn't make temporary objects. Like, it would just assign that memory to the m pointer itself. Like, you can, like, I'll give you some links in the end, and you can look up like how things work.
Sir, doesn't this mean that when that function returns, it automatically deletes the m pointer?
Yeah, we'll come to that. So you basically mean this, right? In this function convert to capital, whenever we are returning in capital, so that will get that destructor will get called and it will be deleted. Do you mean this?
Yes, sir.
Okay, so we'll come to that. Yeah, this is a good question. So do you have any doubts in this class definition? Anyone else? You can also see the bottom two lines. Like, anybody has any idea what I'm doing here? Okay, so I'll give you an easier example. Like, has anyone done a plus plus to increment the value of an integer value a by 1? Yeah, so what do you, like, how does the compiler understands that okay, whenever I'm doing a plus plus, what the programmer actually means is increment the value of a by 1. So the idea is that this operator, that it is a keyword, just like integer, delete, new. Operator is a keyword, and this operator star. What I mean by operator star is I want to override the utility of operator star. So whenever I'm doing something like my class object and then I'm doing star, you have to call this function. So like when we use normal C pointers, when we do star a, so we have a pointer to integer value a, int a, and we do star a, so its value gets referenced, right? So because we are defining classes and it doesn't works like inherently, it doesn't knows because it is a class. So we have to explicitly define the utility of that operator. Like what do we want to do when we do like an object and star. So we are just telling the compiler, okay, whenever we do t star, you actually have to return me the star of the pointer. Okay. And does that make sense? So instead, if I would have done something like operator plus plus for a integer class, integer is also a class in C. Like it can be. Like string is definitely a class. Like it is based on like character arrays. And when you do like string, yeah, like there is an operation for strings in which you can just do like string A plus string B, and then you'll get a string C, which is a concatenated version of these two. Like, has anybody used that? Like string concatenation using plus operator? Yeah,
Yes.
so basically you do the same thing. You tell in your string class that okay, I have this operator plus, and whenever I do like this plus something, you in the return value you just iterate over these two strings and you concatenate and you return the concatenated version of these two strings. So it is this general idea is called operator overloading. You can search more about it to learn more about it. Yeah, so coming to our unique pointer example, I mean, this is not a very good example to show what unique pointer is capable of doing, but it serves the purpose, so we'll just stick to it for now. But I'll be giving you some links and you should definitely check them out for better understanding. So uh, we have len10, we have this character array in small that is algorithms, all small. You pass these two variables to convert to capital. When you go to convert to capital, you declare a unique pointer of class character array that is in capital, and then you assign memory to it. Then you do the things, and you see I have done len here as len, and then you return in capital. So like someone asked that okay, in capital would be deleted. So there is something called move semantics, but for now we can just say that okay, whatever uh, that memory was, even if the in capital variable gets deleted, the memory that it had was successfully transferred to the in capital that is in the main function. Okay, so that delete pointer doesn't get called because the memory is transferred. And now when I do like this for int I and I just print it out and then I do endl, and after return 0, when the scope of this uh, in capital variable in the main function ends. So how many of you know about scope of a variable? What is the scope of a variable?
Sir, the area where the variable can be used.
Yeah. So how is it like if I want to like just check an example. Okay, I don't have code in the slides. So yeah, so do you see these braces after for and here? So if you declare a variable inside this, for example, I say int m and to reference that variable outside scope. So I say, okay, print that variable m here. So do you know what will happen? Will m equals to 20 be printed or something else will happen? Hello? Hello?
Yes, sir, we can.
Hello? Okay, yeah. Yeah, so if I declare a variable integer m inside the scope and I assign it to value 20 and I just print it outside the for loop. So what is going to happen? Will that m equals to 20
Garbage
get printed
value.
or what?
Garbage value.
No, not garbage value.
So undeclared.
Error.
Error, yeah,
Scope, no,
error will
scope.
come. Like the compiler will say that okay, there is no declaration of any m that I know of, and I can't print anything. So you check your code, there is something wrong with it. So what happens is these scopes are like the start and end of a variable's life. So whenever you declare a scope and you say, okay, some variable, and that scope ends. So the moment the scope ends, all the variables inside that scope are deleted. So in your 5th semester, you'll have a course called compilers. In that, they are going to teach you about symbol tables. Like how does the compiler actually knows like what variable has what value, and like how does it like assigns some variable some value, and all those interesting things that come in the between. So uh, like that variable is going to be deleted at the moment scope ends, and the compiler will say that okay, there has been no declaration of variable m and you need to check your code for some error. So in the similar way, like what I was getting to the point was like when unique pointer character in capital, like in the main function, right, this goes out of scope when the main function ends. So this destructor will be called and the associated m pointer will be deleted. Okay, then only it will be deleted, not when like it returns from convert to capital. Like for example, like here we only have 2 functions. If instead of this we had 3 functions, like you can say that, right, main function anyway the function is like the process is going to end. So what is the use of having this unique pointer in the main? Like you should have another function and then you should have called convert to capital so that we could have actually seen that effect. So you can try that out. So like, did any of this make any sense? Okay, I think it didn't.
So that we can get an idea, better idea.
Yeah, so like we are, I think, done out of time now. So uh, what you can do next is like there is this website. So I'll share the slides with all of you. So learncpp.com. This is an excellent website if you want to start off with C++ and learn how things are done and like what um, how you can use C++ in general. Then there is the cppreference.com. This is the official documentation of all that happens with C++. What is the current state of the art? What are the things that like the big guys are looking at, like the advanced research that happens in C++. Then there is CPPCon. It is like the annual CPP conference that happens, and like people come and give talks about what are like some of the peculiar things about C++ that they find interesting, and some other things about like what is good, what is bad about C++, how we should advance it. And then there is the C++ weekly with Jason Turner, which you can tune into if you're really interested in like some of the interesting things about C++. The continuation of this topic would be move semantics. Like if you study more about move semantics, you'll understand how different things are actually done. And like that would be it from my side. So Does anybody have any doubt or like in any questions in continuation of this?